Very good. Sorry, you can understand my English much better than you can understand my Italian, so hopefully this is okay.
Would you like to try some Italian? Like
No. Buongiorno.
Oh, you thank you. Applauso. Martin.
That's it. Buongiorno. My name is Martin Woodward, Principal Group Program Manager DevOps. Martin Wu at Microsoft.com if you want to send me an email. At Martin Woodward on Twitter if you want to shout at me, that's great. And then Visual Studio DevOps is where I live. My title, very fancy, Principal Group Program Manager DevOps. Let me explain that. Principal Group Program Manager means I delete a lot of email, basically. And then DevOps means I delete a lot of email with PowerShell. So there you go. Thanks to Alessandro for having me here and to the team. And thanks to all the sponsors for setting up this event. It's a fantastic free event, so thank you very much. I work on Visual Studio Team Services at Microsoft. Who uses VSTS here? Anybody? Okay, awesome. So most of you know what it is already. So I'm not. That's the end of the advert for VSTS. Let's keep on going. When I joined Microsoft, it was November 2009. I joined from a small startup, and then when I came, this cartoon came out not long after I joined, and I really recognized this as the Microsoft I was joining. There were Windows, Office, and Windows Server and Developer Division, and sort of people didn't really talk together. When Satya came into the company, he really changed this, broke down a lot of barriers inside of Microsoft. So there is now much more one Microsoft, one company. And we have one engineering system in that company now, which is built on top of VSTS, Visual Studio Team Services. So Windows, Office, all these, Minecraft, are all built on top of Visual Studio Team Services, because that's our engineering system. So the same system that you use, we use internally in Microsoft as well for all of our software. Which means we have a lot of people inside Microsoft using VSTS now. As of last week, when I took the chart, 75,717 people inside Microsoft using VSTS actively. This is active. It goes down at Christmas. This is real using it every week. That's a lot of people that we have to keep working and who get very shouty on the telephone if things break. So it's busy, but it's good fun. We talked just then about what DevOps is. This is how we talk about DevOps inside of Microsoft, but it's the same. It's not tools. It's not doing CI/CD. It's people. It's the union of people, process, and tools to enable the flow of value to our customers, to you. We started our journey to DevOps inside Microsoft in 2010, so not long after I joined. When I joined, we were still shipping shrink-wrapped software in boxes that got burnt onto DVDs and sent around the world. And then since I've been in the company, we've moved now to where we're running always-on, always-online services that need to have very high availability, can never go down, hopefully, but definitely never go down deliberately, let's put it that way. And it's been a long journey. We didn't get here overnight. We're not perfect yet either. We are on our journey to DevOps, but we will never get there the whole way. We're just continuously trying to get better and improve as we go. But we started with a product already that we've then, gone to a service, which is what many people with real jobs outside of Microsoft, that's what lots of people have to do. You can't just start from scratch doing DevOps. You have to move to DevOps. So this is kind of the story about our journey to DevOps and some of the stupid things we did along the way, really. So hopefully it's interesting. As we did this journey, we kind of learned 5 lessons. Well, we learned lots of lessons. I've split them into 5 groups because it makes a good talk. But let's go into these 5 lessons. So the first lesson we learned is to be extremely customer focused, to really concentrate on individual customers and individual experiences. Now, we do all the usual things you would expect. You know, we have a user voice site. We have Stack Overflow. Obviously, you know, that's fine. One of the things we also do to build trust and empathy within the product group to our customers is we assign, for lots of the large accounts and some of the interesting smaller accounts as well, we assign a champ, somebody in the engineering team who is directly responsible for that customer. And they talk to that customer once a month, they have regular calls, and if there is a problem with the site or if there's a problem with their account, they pick up the phone to them and tell them, hey, you know, there is an issue. We just wanted to let you know this is what we're doing to fix it. And it's on the engineering team that do this. It's not support. It's not a special team within engineering. It's everybody. Every single person is somebody's customer champ. And that way it helps us build those relationships between individual team members and somebody they know out in the real world using their product. You know, somebody who they know who has experienced pain, or they know likes a particular thing and doesn't want and wants it to get better. So we need to build these relationships up because it not only helps trust in the customers, but it also helps the developers build empathy with what customers need rather than separating that relationship. We also do lots of in-product feedback. If you ever get a prompt that says there has been an error, would you like to send that data to Microsoft? Please say yes. There are people, engineers, who love that data. You made their Christmas by giving them that package of bug report. So please do that. We spend a lot of money on collecting the data. If you can send it to us, that's fantastic. Thank you very much. Don't worry if you can't. So that's just basic listening. But what we also do is, this is our definition of done. So when you were just talking earlier about some of the practices of DevOps, this very much captures some of those in how we define when we can declare a story, a feature has been delivered. When we started our agile transformation, a story was done when it was potentially shippable. Okay? Potentially shippable has a lot of wiggle room. You know, it's very grey. We are done when it is in production, when it is shipped. We are done when it's shipped and collecting telemetry, so data, that allows us to test if the hypothesis, if the idea that we had is better, if we fixed it. Have we made it better or worse? So we do hypothesis-driven development, and a feature isn't done until it's in production, and we know if we've made it better or worse, good or bad. Like going to an optician's and getting glasses, you know, better, worse, good, bad. So we collect a lot of data to help us tell if things are better or worse, and to allow us to ask questions if something is getting good or if something should be done. Right now, we're collecting just under 2 petabytes of data a day, so it's busy. Okay. Now we have to make sure that data has got no PII in it. We have to do a bunch of stuff around that, but it allows us to ask these questions and be able to get real-time feedback as to what's happening in the system. But while we collect data very broadly and we collect lots of data to allow us to ask questions, we are very careful about what metrics we set, what metrics we care about in terms of dashboards and things. So these are some of the things that we care about. And then I'll talk about some of the things we don't care about, which is interesting as well. So we care how satisfied our customers are, how many customers we're acquiring, and things, and churn. So that is, how many customers do we lose, you know? And where do we lose them? Well, during the sign-up process, there's a big funnel of people coming into the system, and then they stop at certain points and don't create accounts or don't go on to, they might check in code, but then don't create a build and then go away. Why? And we look at that a lot. We spend a lot of time understanding churn. A feature and the success of a team is judged by how much their feature gets used. That's the main success criteria. How much their feature is being used. Do people like it? Do people use it? When we're looking at how quick we are, how fast we can deliver, we look at how quickly we can build, how quickly we can test, how quickly we can get into production, and then how quickly we can learn. It's no good being able to throw lots of things into production really, really quickly if it takes us 6 months or a year to know if we've made it better or not. So our time to learn has to be fast as well as all these things. When we look at the live site, we care about how quickly we detect problems and how quickly we can fix them. And by fix, I mean, let's say mitigate. So that means make sure that the customer is no longer impacted. But that may not be fixed. That might be just make sure everybody doesn't know there's a problem anymore. Then we also look at our prevention items, and then we have to fix them. I'll talk about this more in a second. Here are some of the things we don't care about as a company. We don't care about at the high level. We don't care what your original estimate was for a feature, okay? I don't care. I care about how much time is remaining on a feature. Actually, I care when the feature is shipped, to be honest. We don't track estimates. We don't track how many hours you worked on a feature either, because I don't care. I care about how many features are being used, not how long you spent building them. We definitely don't care about how many lines of code you've written as a developer. If you come in and you've removed 1,000 lines of code, that is the best day you've ever had as a developer. So, I hope nobody's tracking that anymore. And then we don't look, as a management team, we don't go to the teams and figure out what they say their velocity is in story points and things like that. We don't care. What we care about is how many features are being used, okay? Let's talk about features. We mentioned it earlier about feature flags. This was something we've built in, and you see it if you're a user of VSTS. You actually have the ability to switch features on sometimes. So I'll just explain this because it's got some interesting problems as well. We use feature flags because we always check in code into master. We're always integrating. We don't want to build up any integration debt. Okay, so we always integrate into master and then we ship. We shipped the first version of Git, so we know we provide Git. We shipped that in TFS 2013. If you go to TFS 2012 update 4, which was the last 2012 update before we shipped 2013, the Git code is in there. If you know the secret key, you can go in and switch Git on in TFS 2012 update 4. The code is there. It's just not activated because it wasn't tested and we weren't convinced it was ready yet. So these feature flags control everything. The code is there and integrated. A feature flag is a fancy name for an if statement, basically. Okay, so you put a bit of code in. You say if feature is on, branch, and then you go write the code. And then now at this point, you have two branches that the code path can go down, and then you can just simply toggle, the feature on and off. And we toggle that feature at lots of levels. We bring it on for internal testing to begin with, then we make it wider. We open it up to our MVPs very early on to get feedback. And then at certain points, we make it so actually users can opt into a feature themselves. One of the things we track with new UI, user interface, is we track of the people that opted in to the new user interface, how many opted out again. Because if you opt out, that new user interface is not working because you've switched it off. User interface is like a joke. If you have to explain it, then it's not working, okay? And so we make sure the opt-out ratios are close to 0 before we then will roll out a user interface change to everybody. And then once we've done that and we've got the feature, we think it's all done, we then have a process to remove the feature flag and get rid of the code. So we have warnings to find code that's there for feature flags that no longer exist. And then that way we don't end up with lots of if statements polluting the code, because otherwise it gets really hard to maintain. Now, feature flags are great. They provide lots of advantages. One of the things the marketing people really like is the ability to do a dark launch. So basically, we can have the feature, it's rolled out in production, and then one morning, Scott Guthrie walks on stage and says, feature X is available, ta-da! And we switch it on and everybody has that feature magically, okay? And marketing people love that because it's big news, it's exciting, it's brilliant. It's a nightmare, okay? We did this once, not too long ago, 2014 I think this was, where Scott Guthrie was coming on stage. We'd had the feature tested, we'd been using it with our MVPs, we'd had it with beta testing customers. It was working fantastic, okay? Scott Guthrie had done his demos repeatedly, in practice. We'd had lots of rehearsals. Everything works fantastically. Brilliant. We switched the feature flag on as Scott Guthrie is walking on stage. Now the whole world starts using the feature. And sadly, with live load traffic, it caused a cascade failure and brought the site down. As Scott Guthrie is trying to demo that feature live on stage. That's not a good way to get a pay rise, okay? It didn't go great. It was out for about a day, actually. It was horrible. So we don't do that anymore, okay? We switch feature flags on at least 24 hours before any big event, if we're going to announce them. So anybody here on Twitter or blog and things, then just go use Azure the night before, build or ignite or connect, and you'll find all of the features enabled. Now, you MVPs, you're under NDA, so you're screwed. But everybody else, they can blog about those, and then that's great. You can now be the next new walking cat. So it'll be amazing. So there you go. But don't tell them I told you that, okay? So the next one is, obviously, once we start breaking the site, we now have to have what we call a production-first mindset. With dev and ops and devs deploying into production and, rapidly getting things into production, how do you stop things breaking all the time? You call the developers up out of bed when things break, and then things will stop breaking, okay? So we needed to build a production mindset so that people cared what was running in production. A feature isn't delivered until it is in production and running. It's not delivered when you hand it to QA. There is no QA anymore. It's not delivered when you hand it to ops. It's delivered when it's running in production. So to be able to say at the end of your sprint, you have delivered a feature, it has to be running in production. When there is a problem, like we accidentally crashed the site, we fire what's called a live site incident. Microsoft love three-letter acronyms, or TLAs, as they call them inside Microsoft, seriously. And our LSIs, as I say, live site incidents, it's basically a phone call, a phone bridge, conference call. So when an incident happens, a conference call is immediately created by a robot with Satcha's voice, scarily, and Satcha rings you up and says, hey, the site's down, you know, come on to this, you're being brought into the phone bridge now, fix it, kind of thing. Everybody gets on that call. We have a notion of a directly responsible individual, DRI. That person is called, they come onto the bridge. Other teams that need to help to fix this problem are brought into the call, and it is fixed in the call and mitigated, and then we go fix it. These calls are very widely communicated with inside the company. Sometimes, if it's a really bad problem, Scott Guthrie joins the call, which wakes you up. Some days, Satcha joins the call, and that really wakes you up. You know, so people take this very seriously. But as senior managers within the business, it's our job to make sure teams understand, yes, this is the most important thing to the business right now, is fixing the customers, getting them back up and running as quickly as possible. So this is the most important thing to the business, is the health of the live site. When we do have problems, which we try to avoid, but last week was not a good week for me. I was very tired last week. I'm glad this week is better. We had a live site incident last week where we had a problem. It actually turned out to be regular expressions that caused the problem, which is classic. You know, if you try and solve a problem with regular expressions, now you have two problems. This was what happened last week. To be fair, it wasn't our regular expression. It was one in a library that we were calling in, and it brought a new regular expression in that didn't work very well. Once you had people from lots of locales using the system, is basically what happened. In our internal testing of live, everybody was in US English. And then once we opened it up to production and everybody from different locales was hitting the site, then it hit a caching problem and all heck broke loose. And there's a blog about it because we're very transparent about what happened, okay? And we try to be very, very transparent. Now, I'm saying to you here, it wasn't my code because we're friends here. We didn't say that when we talk to the customers. You know, when we're talking, it is our fault. It's our site. We are responsible for fixing it. It doesn't matter whose code it is. If you're a user of VSTS, VSTS is down right now, or it wasn't down. It was performing very badly, performing very slowly. So you don't care. We have to fix it, and that's what we say. Yes, that's our problem. We will fix it. How do we fix it? Let's get it working. And we ended up patching an AAD library, Azure Active Directory library. We ended up having to patch that library, getting in production super quick, and off it went, and it was fine. The key to be able to doing this is having really good alerting. And this was an important learning we had. When we first did lots of alerts, there was just, you know, if you look at go into Windows Event Viewer and you see all those events that come up, and imagine if you had an alert for every time something went into the Windows event log. It would, you know, you would never listen. And so people used to ignore alerts and didn't realize they were urgent and things. So we've done a lot of work to make sure our alerts are very, very targeted. A false alert is a fault for us. We need to make sure alerts are actionable and then have a sense of urgency. And in fact, by doing that allowed us to make it so we didn't need a team in front of the alerts to filter them. When we have alerts, it actually the system figures out which part of the code base that alert belongs to, and then calls the people that own that code, rings them up, wakes them out of bed, and gets them on the call and starts telling them to fix it. The next thing we learned when we started doing this is there's no such thing as partial automation. Just like you can't be partially pregnant, you can't partially automate when it comes to deploying a live site, okay? Here's a great example of something that happened when we started. We would say, here's the code, checked in. Here's the build, repeatable, checked in. However, to do the deployment, yes, you need to run this code, but here are a set of steps that also have to be run. And that would be a set of instructions, typically, in a OneNote file or somewhere that somebody had to execute on production. Now, here's an example of one. Apart from this being in PowerShell, anybody else see any problems with this particular bit of script here? Smart quotes. Okay? When you copy-paste these things around in emails and OneNotes, it auto-corrects them. And normally you realize that and you fix them. But sometimes you forget and then you try and fix them manually. Sometimes you don't notice it went wrong when you're in the rush and you're trying to deploy this across hundreds of machines. And that happened once for us because we had lots and lots of steps like that. And we forgot one and because it went wrong because of the smart quotes. And then we took the site down for a day. Okay? Not good. That's not a great one to try and explain in your blog post from Brian Harry explaining why the site went down. Oh, somebody typed it in wrong. That's not good. So now we automate everything. The only way to get code to run on these production machines is actually to check it in as a script, and then we roll it out using VSTS release management. So we ship Visual Studio Team Services using Visual Studio Team Services, which is interesting. But what gets more interesting is Visual Studio Team Services ships on Azure. Azure build Azure in Visual Studio Team Services. Azure is hosted on a lot of Windows boxes, okay? Windows deploys to Azure using Visual Studio Team Services, which I've lost it, Inception, okay? So we do have a backup, as I was explaining over breakfast. It involves a computer hidden in a mountain in Nevada, but hopefully, in case we go really wrong, but hopefully that won't happen, yeah. When we deploy to these environments, we actually have five rings of deployment. So I'll just explain these. The first ring is the canary ring, we call internal users. So that's where we live inside Microsoft. So that's my account is on there. Some of the ALM MVPs here actually have machines in the canary ring as well. And the idea is that we deploy to that first, and we should know very quickly if there's a problem. But it's only impacted people we don't care about, i.e. us and those MVP people. Who cares about those people, It's not affecting paying customers, let's put it that way. So we need to, or it impacts people who know how to get themselves out of trouble as well, as important. So after that, we roll out to our smallest external data center that's got people, real people with real jobs running on it. Again, this is classic testing. So we go to our smallest data center first with real production load rather than just our load. And then we go to our largest data center next. So if we can handle the deployment to the smallest and we can handle the deployment to the largest, then we know we're in a good place. The next one is we deploy to the furthest away data center from where we kick the deployments off. So we go to the furthest international data center, and then finally we do everybody else. So that's kind of the order that we do it in. We do the international data center because it's latency, to make sure that's not going to cause a problem. Usually things go green. This is actually a live screenshot from release management inside of this is our account here, MSeng. And you can see usually it's all green, which is great. But occasionally, you get that happen, which is awful. So it went fine all the way, and then when we went to everybody else, it went wrong. That's called a live site incident there. That's a problem. And then you get this sometimes as well, which isn't as bad, where when we tried to deploy it to Canary, we found a problem. So then we obviously don't deploy elsewhere. But usually you get that if it's a good day. So with live site culture, it's important that the live site status is everybody's top priority. I was giving a keynote last week, and yet I was on the live site call because live site is the priority. And when we are looking at how well the site is performing, when you have a large site, it's very easy to keep that site with a high availability. In fact, when we had this horrible problem last week, the site never went down, the site never stopped working, it just got really slow for people in Western Europe, mostly. So what we do is we focus on the individual customer's performance and how quick their accounts are performing, not the overall live site figure. We focus on what is the worst customer experience we're seeing right now. Okay. The next thing we do is, obviously Microsoft's very secure focused. With live services, we do what we call red teaming. So basically it's penetration testing or pen testing. We have a red team and a blue team. The red team are internal to us, but they know the system really well, and they're all hackers, basically. So we have an internal team of really, really smart hackers who also know our system incredibly well. The most dangerous combination, okay? We then have the regular team who are trying to spot intrusions to make sure they can tell if somebody's got into the system. Every quarter or so, we run a red team exercise where we have our internal hackers try and hack us. And the blue team, we see if they spot them. And then we take the learnings from this and improve our processes to make sure we don't have the problem again. The horrifying thing is the red team always win. Okay? Always. They always get in. It's very, very sobering to every developer, which is a good thing. Because you start thinking very much more defensively. And actually, when I get emails, every single email I get now, if it's a slightly strange or reads too good to be true, I just assume it's my internal red team trying to phish me, because they can do anything to try and get in. You know, when they started, they just crawled network shares and looked for password files. Like, you know, it was lots of low-hanging fruit to begin with, but everything got better. But now they phish people. They do multi-level, zero-day, you know, exploits with JavaScript and things, and all sorts of tactics to try and get in. But they always get in. So, do we detect them? What can we do to improve our process to stop the fault that they found next time and improve the way that we do things? Luckily, we nearly always detect them now as well, so we're getting better. Next one is how we organize our teams and how we have our team autonomy. Software isn't making sausage. You make great sausage here, you know, and ham and things. It's not like that. It's not like making a bridge. It's not like civil engineering. It's a very creative art. And it involves creative problem solving. If it didn't, then we should just be buying software off the shelf. A book that was very influential to how we think about teams is this book called Drive. There's a 5-minute YouTube video version of this as well, if you want, so you don't save reading the book. But it's very good. You want lots of autonomy in your software teams. Ideally, you would give them complete freedom and let them be amazing. However, in a large company, if you have everybody with complete freedom being amazing, you end up with a car crash, okay? Because nobody's talking to each other and nobody can communicate. So we have to have autonomy of teams, very deliberate, give them control, but have some areas where we align. So we give the team complete autonomy over what they do, how they plan, and how they deliver it. But we have a certain language that we keep aligned inside the company in a certain pace. So let's talk about what happens when you don't have when you have too much autonomy. The Windows team are using VSTS. When that happened, originally the Windows group were going to move over and get together and migrate into a new system that they used. It was a thing called Product Studio to track work items. They were going to do that over a year. They'd had a plan they'd worked on for ages. That was all good. One day, Satcher came together with Terry Myerson and my boss, a guy called Brian Harry, and was like, hey, we're going to move Windows to VSTS. I was like, okay, awesome. We're going to do that in 2 weeks. And I was like, oh, okay. I've still got the scars, okay? Yeah, it was. I used to be like really slim, had loads of hair, and it was all black, and then Windows happened. So it was hard work. When these kind of things happen, you say yes to a bunch of crazy that you shouldn't have said yes to. Okay, you build up process debt, and so some team in Windows asks for something, another team asks for something else. You just say yes to everything because you're trying to get them in. And what we ended up with is this is the custom bug defect work item type for Windows. This is all the fields in it. Because basically every team in Windows wanted their own field, and it just was oh, sorry, hang on a minute. This is the Windows bug work item, yeah? It was ridiculous. And then when we did some analytics, we found nearly 50% of the time of a Windows developer was spent updating work items, not coding, which is just stupid. So we need some alignment in terms of what are the fields that we need. Within Windows, what we did is we created a Jedi Council, and the different groups in Windows now have to argue for or against a particular field, and we let them fight. And then they tell us, they tell us the answer, and we make it happen. The way our teams are structured, we used to have program management, which is where I live, because we've got ties, apparently. And my developers have got ties in this diagram, which is very unusual. And then we had program management, dev, and test is how it used to be. We actually got rid of the test discipline inside Microsoft, so there's now one career path, which is engineering. We still have people that are amazing at testing and are great testers, but everybody is in engineering. Everybody is in that career path and is judged on that success of how quickly they engineer features into production. We do have specialist ops people, site reliability engineers, but what we do is we bring program management, engineering, and ops together into one team. And then that team is the people that are responsible for delivering into the customers. So they are all sat together. Just, you see, the people in this suit, this color of suit here, have a slightly different career path to these people, but they're all in one team at this point in time. Those teams are all located together in one room. We actually knocked down our office and rebuilt the offices to make this happen. So we put the whole team together in one room, and then around that room we have little meeting rooms that they can go off and have conversations and things. But we physically co-locate them. We have development in India, North Carolina, Redmond, and then we have a few people scattered around in Europe and things. We don't do follow the sun development. Okay, we don't have people across those different continents working on one thing. They all own an area because they're responsible for it, and they're responsible for it working in production. We all know the further somebody is from you in terms of physical location, or the further somebody is from you in the org chart, the more stupid they are. That's a fact, okay? And so we realize this, and so we put people together and make them work on a feature and own the feature together. And they are formed as a team. Sometimes when we're planning, the work we're doing changes because we have new priorities. We keep the team together, but we might change what it is they work on. And that's important. So the teams stay formed. However, we can't keep teams locked forever, for all time. Because if you're somebody who's ambitious, if you want to try new things, if you feel stuck in a particular feature team, you want the opportunities to grow, to learn, to do something new. And so we need to be able to provide that within our group, otherwise we will lose these people. So what we actually do is we do what we call a sticky note exercise. So every 12 to 18 months, we get the teams, the engineers within the team, can choose which team they work on. That's as a manager, that's hugely scary, you know. But I have to go in, and we have a big meeting. I go in, I pitch what my team's working on, and why. Why is this the most important thing you could come work on in the entire team? What we're going to be doing, and then people get to decide which team it is they work on. It's fairly unique inside Microsoft. Not many teams do this yet, probably because it is so scary. And but what it does is it allows opportunity for the team to move around within our group without having to leave, so it gives mobility. We are usually able to, I think it's like 99, 98% of people's first choices, we're usually able to accept and have them in that team. They get a first, second, third choice. And so most people were able to get them where they're going and still have decent-sized teams. But we do that, let's say, every 12 to 18 months. We've just done one now. Let's talk about how we plan. We have a scenario. We know where we're going to be roughly in 18 months' time. That's some bullet points, you know. It's very, very rough plan, kind of know. The season, so 6 months out, is the thing that I have a good idea where we're going to be. But that's in terms of wireframes and mock-ups and screenshots, you know, kind of where we're trying to get in 6 months. And this is the point that we as management sort of talk to teams at the 6 month, where do you want to be? From here on in, it's all the teams. So they own their 3 sprint plans, and they own what they're going to do this sprint. And a sprint for us is 3 weeks. It just worked out well for that. So they know what they're, and normally what happens is the team knows really, really, really well what they're going to be doing this sprint. They know pretty well what they're going to do for the next 3 sprints. You know, sprint 3 is always a bit, meh. And then they know where they're aiming for in 6 months' time. Every 3 sprints, we will update the 6 month and the 18 month plans. We update these all the time. So we're constantly looking forwards at where we want to go and keeping it up to date. Because if we look at planning, people often get confused about planning. The value of planning isn't in the plan that you create at the end, because that gets thrown away the minute you start working. The value of planning is in the act of planning, is in the thinking and the preparation. So if you look at the value over time, traditionally from planning, the most value you get is quite early on in the process. So what we do is we just keep replanning, basically. So by replanning, even though we don't plan as much, we plan shorter, we get these little increments. And that's the only reason why Agile works, is because you're constantly replanning, and so you're constantly getting this high-value part of the planning curve. But overall, you deliver more. Because we're a large team, some of the ceremonies of Scrum don't really work great within really large teams. You know, we have like 700 people working on VSTS. So what we do is we have, this is how we talk to each other. This is how we stay in sync and have some of those ceremonies. Rather than, rather than have everybody see the sprint planning and come in and see the retrospectives and things, we actually send to the wider team, from each feature team, one email. That contains what we did last sprint, what we're going to do this sprint, but it also, and this is the only bit, to be fair, I don't tend to read the emails much, it contains a sprint video, and the sprint video is a demo of what they've delivered into production that has telemetry that's collecting data back that helps them learn. So the rules of that sprint video are no production values, okay? Because when we first started this, Microsoft's a very, we have lots of alpha nerds. There's lots of very, very smart people working there. When we first started saying do sprint videos, people started doing amazing Star Wars credit sequences, CGI, laser beams, dancing, all that sort of stuff. No. There has to be no production values, just an over-the-shoulder recording, just like this. It has to have no sequence shorting. They can't make an edit. If you can't fit your feature into a 3 to 5 minute video without editing, or if you have to explain it, then the feature isn't good, okay? It needs to be able to demo in a short amount of time over the shoulder. Next, we have these team chats, and we're going to talk a little about this later on today in one of the sessions. But basically, what we do is we get the teams together, and this is where they coordinate, and they basically very, very quickly say, hey, what they're going to work on next, what if they've got problems with debt, like maybe they've got some issues with bugs, or some feature problems, or some integration debt or something, and anything they've got blocking them. And they do this together, so the lead of the team does this with the other teams, and this allows the teams to communicate directly. There's no middle management. The teams communicate directly with each other about what they're going to work on, and then we as senior managers will come in and we'll just sort of say, well, hey, like, you're kind of working on a similar thing to this team. Do you want to talk to each other? Or, ooh, this team just said that thing's not going to be arriving in sprint 125 anymore. It's going to land in sprint 127. How does that affect your plans? So we do that very much as peers within the teams. And then finally, our 6-month plans are in terms of what we call experience reviews. So an experience review is basically a wireframe, a plan of what the customer experience is going to be. It's not a list of requirements. It's not a set of work items at this point. It's literally, what is the customer experience going to be when we've built this feature? And that's what I mean by customer focus. We don't have anything about how much time is going to be. We don't have estimates. We don't have hours. Literally, what is the experience going to be? Give me feedback. Give me lots of feedback about what you think. Are we building the right thing? Right then, we're nearly there. Shift left. So in the old days, and then this is the bug count for Visual Studio TFS 2010. We had, like a beta 1. No, that would have been like early preview. That would have been a beta. This will have been a release candidate, and that'll be when we shipped, probably about there, and then that's like update 1 or something. That's probably like service pack 3, probably, or whatever, So that's exactly what happened. And you see what happens is we go into this, we build up debt because we know we need to get a release out. And we build up this big pile of debt, and then we pay it down, and then we build up another one, and then we pay it down. And these periods here, they're no fun at all. Just fixing bug. Not fun. It's horrible. Everybody hated them. And what we used to find is people would play games. People would deliberately check in a bunch of stuff they knew didn't work because they knew there was going to be a big stabilization phase, and they would get it working then. That's not good. So when we're doing more agile, as we're doing more agile releases, as we're shipping into production, you can't do that anymore. You can't build up that set of debt. And so we find now that our bug counts actually are very low all the time. And they just, they go up within a sprint and come back down again. But we don't build up this massive pile of debt that we then have to pay down over weeks and weeks. So it makes it more fun. And in fact, if you look at the Stack Overflow survey from 2017, the happiest developers are developers that ship often because it's more fun, okay? So enable continuous delivery, and you'll have more fun as developers, you'll have happier developers, and you'll have happier customers because they get to see things more and build up trust. To do this, we had a lot of tests, but all of our tests were kind of integration level tests. Does this system work? There was a lot of manual testing in there and a lot of UI automation testing. So we had to move our test portfolio from being lots of integration tests to being more unit test focused, to being more repeatable. And so that's what we did, but it took us a long time, okay? This is the actual counts of the different types of test. This is milestone 78, and these are all 3 weeks. Each one of these graphs is 3 weeks. But over that time, we eventually got to the point where we have a lot more integration, a lot more unit tests that are repeatable, and not as many full environment end-to-end tests, which are not as repeatable. The advantage of this is now our test suite can be run anywhere. It can be run against production, or it can run against the different environments. And it is 100% reliable. Any failing test is itself a bug. So a test that isn't reliable gets removed, and we write a better test. because you need reliability of tests. You need to be able to count on them. Otherwise, it's not a test. It's a guess. And we run our tests after. So we run our unit tests, our L0 tests. Actually, we run these two. We run these in the pull request. So when we do our code review, we run these before we even merge them. And then we run all of our test suites once it's merged into the CI build. Let's talk about pull requests. So we use Git now for most of our projects, and we use pull requests as the point of code review. This is a screenshot of a live pull request. Part of the pull request is it obviously runs the build. So before anybody even bothers to read the code, it builds it to make sure it works. Okay, and then it runs all the tests, and it also runs some security tests there as well. So here is a we're checking here that somebody hasn't accidentally checked in credentials, for example. That we maybe did or did not find that as part of red testing, and we never want that to happen again. So we added something into our pull request to stop code that has credentials in from ever getting merged. You have to externalize your secrets. And then we do the code review, and somebody else from the team has to be able to approve that pull request before it gets merged in. It's very common for the build to fail in the pull request. That's fine, because you haven't broken anybody. It's just your little area of code. It's very, 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 very rare for the CI build to fail now, because of all the testing that happens at the pull request before we even merge the code in. And then the final part that we're on is moving to treating infrastructure as a flexible resource. When I first joined Microsoft, I got given a big server, like a massive workstation, a laptop, and off you go. And so we used to have lots of VMs running locally, lots of hardware running locally to test things on. We've moved from having those sorts of things in labs to virtual machines, and now we use Azure Dev Test Labs. So I get given a laptop and an Azure account. Is not what I get now as an engineer in Microsoft, and I can fire up lots of resources. I get a fairly blank checkbook to go create machines in Azure. It's not completely blank, but we use Azure for dev test all the time. What we do with our Azure bill, interestingly, is it's rolled up at the manager's level. So as a senior manager, you know how much your team is spending, and then we compare senior managers together. But as an individual dev, you don't care about it. You just know that your machine gets automatically switched off at night, and you have to switch it back on again, and things like that. You just have to look after your own resources, and you'll get told off if you use too much. But normally, people don't care. We are shipping the same code. VSTS ships in production, and it ships inside of Team Foundation Server. It's the same code base with an if statement. Am I running in Azure or not? Okay. And because of that kind of impacts on how we do our infrastructure. So what we did is we actually have a service inside of VSTS that's called TFS. And that was the original version of TFS that was just the code. And we've slowly pulled TFS apart into two services, TFS and SPS. And they're split. And there we have cross data center resiliency there as well. That gives us. So we split it out into two services. So from one big monolithic thing to two slightly smaller things, but still fairly big. And they're in multiple data centers. We can have that. That's all great. But then what we're starting to do now is all new services are actually being built as microservices and are being delivered as containers. So things like service hooks, they're all containers now. And we're slowly containerizing services as we go out. But by a long way, not everything is like that, okay? Because, again, we've got a 15, 20-year-old code base that we're bringing along, and so it's taken us a long time to get there. Why containers? It allows us to ship the same code on-prem as it does to the cloud. If we were deploying just to the cloud, we would be using PaaS. We'd be using Azure Functions. We'd be using worker roles everywhere, but we're not. So by doing containers, it allows us to get a lot more cost savings and some of the flexibility that we need, but it allows us to go to the cloud and on-prem. And currently, as I say, we've split it out. Linux, if you use a Linux build host, that's also just a Docker container, really, is all that is. Whereas the Windows builds are a VM, is how that is. Right then, this is me now. So the final thing is, look, it's not like there's no smoke and mirrors. DevOps isn't this amazing magic, thing that you can just do. DevOps is a journey that you go down, and it's important to you to just continually try and get better each sprint. Just get a little bit better every time. Don't think that, oh wow, just because Microsoft have got this amazing robo-dialing Satcher and machine learning alerting models and blah blah blah, I'm never going to get there tomorrow, therefore I'm going to give up. No. Set up CI/CD, set up the ability to be able to automate deployments into production, even though it manually approved, but still automated. Just get a little bit better every time. And if you get a bit better and you look at how quickly you can get better, then before you know it, you'll be, amazing DevOps, whatever, guru. And then there'll be some other buzzword after that. So that's fine. But there we go. Okay. So that's about what I had. I wanted to give some time for Q&A, but thank you very much for your time. And again, thanks to the sponsors for putting on the show. Thank you.